Okay, we should see. Okay. All right. Welcome everybody to the Explainable Fuzzy Challenge for 2024. I'm Tim Arnett, the lead organizer, and today we're going to show off the competition between a bunch of student-created agents that were developed and trained to play the Python arcade game Kessler. So the agenda for today, I'm going to go over some intro slides talking about XFC and the teams and what they did, along with some words from our sponsor. Then we'll do our student presentations, and then immediately after that, we'll go ahead and get into our competition live stream. This is being live streamed on YouTube. I believe everybody should have the link, but if not, I'll put it back in. I'll put it in the chat actually right now. So everybody should have that link. And then we'll show the playoff results and then close with some closing thoughts. So an introduction to XFC. The Explainable Fuzzy Challenge is a competition using fuzzy logic and machine learning methods to play a video game. Students create an AI system to control agents in the Python arcade game Kessler, which is based on the classic arcade game Asteroids. And the AI agents that they develop need to explain their actions. This is partly a learning experience, so there are multiple seminars given throughout the year to the students in order to help them along the way. There was one on fuzzy logic given by myself, which goes over not just fuzzy logic, but fuzzy inference systems, fuzzy trees, how to develop them and use them in these types of systems. We also had a talk on gradient-free optimization with a focus on reinforcement learning with Dr. Nick Ernest. He's given that talk multiple times. It's really good. We also had multiple talks by Dr. Barnabas Bede from DigiPen, one on gradient-based optimization in fuzzy systems, and then another on reinforcement learning with fuzzy systems. And then also Dr. Scott Dick from the University of Alberta gave a talk on explainability in fuzzy systems. This year we started off with 9 students on 5 teams. That was who registered. And then at the end we had 4 teams that submitted agents for the competition today. So XFC, more generally, there are a number of goals that we have and the motivation behind actually running this competition. In the short term, we want to foster student development for skills relating to things like Python and object-oriented programming, and more generally software development. One of the big ones is repository management. That's something that some classes don't focus a lot on in engineering, but they could use a lot of. And then also machine learning, including reinforcement learning. We also focus on gradient-free and also gradient-based now optimization, and also application of fuzzy systems towards interesting and relevant problems. And then of course also explainability of these types of systems. In the longer term, we also want to disseminate these skills into the workforce and research areas, and we also want to improve XAI and fuzzy adoption and understanding. So that's some of the motivation behind XFC, plus it's a lot of fun. There's a Python-based game that we use, and students get to play around in it, develop an agent that can play it. It's a lot of fun. A little bit of history from past XFC iterations. The very first one was in 2021. This used a version of the game called Fuzzy Asteroids, which we modified a Python arcade game called Asteroid Smasher. And it wasn't really meant to be used with machine learning, so the performance kind of suffered. But we had 3 student teams compete in that, and they did very well. And they only had 1 semester that year to complete that. The next year we went to the full year and we added more seminars. We extended Fuzzy Asteroids to be in multiple vehicles, and the agents had to control both the single and multi-ship scenarios. We had about 12 teams signed up at the beginning of that year, but only 2 submitted final agents for the competition that year. And we've kind of kept that format since, where we do the entire academic year. We have seminars and other learning-based meetings and videos during the fall semester generally, and then we reserve development for the agents towards the end of fall and then into spring. In 2023, that was our third competition. We switched from Fuzzy Asteroids to the new game Kessler. This was a similar game, but it was developed by Thales to be easier to use for ML and RL development. So it's much more efficient, it's easier to use. It is also open source and it is available here on GitHub. And it's also on PyPy, and you can install it with just pip install Kessler game. Last year we had 3 teams submit final agents, and we continued the same seminars as 22. This year there was a slight change in that Kessler added mines, so not only do the ships fly around and shoot asteroids, but now they also have mines which they can drop, and after a certain time the mines detonate and hit anything in the blast radius. One thing that's interesting is that the ships can't shoot each other with bullets in the game, but the mines will damage anything that is in the blast radius when they detonate. So they can be used to hit asteroids, they can hit yourself if you're within the blast radius, or they can hit the other ship. So we're expecting to see some interesting behaviors. We're kind of curious what the agents learn to do with them. The recordings for XFC are on our YouTube channel, which you can find here. You can also find it just by searching for XFuzzyComp or Fuzzy Competition. This contains all of our seminars, our prior competitions, highlight videos, etc. There's some other things in there like help sessions in Python and Kessler itself. There's a lot of material in there. This year we'll be adding most likely some of the student presentations so other students can see what some of the other solutions have been in more detail, maybe help them get a head start. The organizers for the competition are myself, Dr. Tim Arnett. I'm a senior AI researcher at Thales and the lead organizer. Also Zach Phillips, who's in the same office as me. He was the primary Kessler developer, and we maintain that repo. Also Lynn Pickering, who's a PhD student at the University of Cincinnati. She helps with general logistics for the competition. And Sam King, he is an engineer at Intramotive in St. Louis, and he also helps out with general things with the competition, especially the website. For the explanations, we use a judging panel where they evaluate the agents that are submitted and the explanations that they output. And the judges then rank and score the solutions based on the quality of those explanations. And so the panel that we have for this year is, again, Sam, Zach from Thales, also Dr. Brandon Cook, who's an engineer at NASA Ames, and also Dr. Nick Ernest, who is the chief architect here in the Cincinnati office for Thales. They also evaluate the solutions based on their innovation, because there are also prizes for the most innovative solution. Some of the criteria that they use to judge the solutions are ease of understanding, the quality of the explanation, the sensibility of the actions from the explanations, and also, like I mentioned, the innovation. In order to do this, we run them through a number of different scenarios that are dedicated to elicit these quote-unquote explainable behaviors. So really what we're trying to do is we're going to put them in a situation where we expect them to do, or we don't know what they'll do, but we want to see what they will do in a particular situation and understand why they performed the action that they did. A little more on Kessler. Like I mentioned, this is a game inspired by Fuzzy Asteroids and Asteroid Smasher. It was written from scratch with minimal dependencies. It's created to be more easily used with ML and RL. Much more stable and fast, and there have been some recent improvements thanks to actually the competitors in XFC. And the interfaces are very similar to the old game. We do have multiple graphics options, including Tkinter and Unreal. So if you use the game yourself, you have multiple graphics options, but all that's in the documentation on the repository. A little bit more on the game itself, though. This is a 3-degree of freedom simulation, so the ships can rotate, move forwards and backwards, fire projectiles, and drop mines. The ships and asteroids do wrap around at the edges of the screen, but the mines and bullets do not. When the asteroids are hit with projectiles or a ship or a mine, They split into smaller pieces, specifically 3 smaller pieces, until they reach the smallest size, and then when they get hit after that, they disappear. Any piece of asteroid or ship-on-ship collisions will take a quote-unquote life from the ship. In the scenarios that we're evaluating today, the ships will have 3 lives, so essentially they can be hit 3 times before they're out of that scenario. They do have a respawn period where they are invincible for multiple seconds after getting hit, though. Kessler is also made to be adversarial, or it doesn't have to be adversarial, but you can have multiple ships in the same game controlled by different controllers. And one other thing to note is that the ships can only shoot asteroids. They cannot shoot each other. So mines are the only things that they can lay down to affect the other ship, besides hitting them with your own ship. They're going to be evaluated over multiple scenarios. The initial conditions will be different. Some are designed to elicit certain behaviors. Some are designed just to put them in bad situations and see if they can get out of them. And some are just fun. We do have a couple in particular that are kind of fun to see what they'll do. Not all of them have a simulation time limit of 30 seconds, but that is the general limit for them. There are some that are a bit higher just because we want to let them go a bit longer. And then the explainability is similar, where we have initial conditions for the asteroids and the ships such that we want to see what they will do in that exact situation and have them explain why. Oh, one thing I didn't mention with the explainability. This year, the explainability portion will be done offline. It won't be done during the competition live stream, but we will be recording those when we do them offline, and they will be uploaded to the YouTube channel afterwards. So I mentioned that we had 4 teams this year. We had one from the University of Alberta, Team Neo, and the competitor there was Jai Fan. We also had Team Amulets from Osaka Metropolitan University in Japan, and the competitors there are Eric Vernon and Ayato Tomofuji. Then we also had Team 360 No Slope, I like the name, from DigiPen, and that was Leo Huang and Garrett Obenchain. And then we also had Team Fuzzifiers from DigiPen, and I apologize if I'm mispronouncing names, but that was Mabugua, Nathan Del Campo, and David Mann. We also encourage teams to submit custom sprites. We actually have a peer award for custom sprites where all the teams vote on which of the other sprites they like the best, and then we give out actual monetary prizes for that peer award. So these are the custom sprites that we had this year. Team Neo is this one on the left. Really fun, kind of classic arcade looking sprite. Team OMU went a bit of a different route, and they submitted their sprite based on an egg and rice omelet, but I'll let them describe that more in their presentation. And then also Team 360 No Slope submitted theirs, which is also a fun spaceship design. And we actually have the results from their voting, which we'll get into a little bit later, but you'll actually be able to see their sprites playing the game. So that's a little bit more fun to have your custom ship flying around. The way that the scoring will be done for the competition, it's based on the number of asteroids hit during all the scenarios evaluated. If there are ties in the asteroids hit, there are tiebreakers based on accuracy and then total deaths. And the playoff seeding was determined by scoring their agents. They had to submit a qualifying agent against a baseline agent that we created. And so the higher the score, the higher the seed. So the way that we're going to have the playoff today, it's a 4-team single elimination bracket with an additional playoff game for 3rd place. So in round 1, we'll have seed 1 versus seed 4. Then we'll have seed 2 versus seed 3. Then the final round for 1st and 2nd is another match between the winners of round 1. And then we'll have an additional match between the other 2 for 3rd place. The way the scoring ranked them in seedings for the playoff bracket was Team Neo was the 1st seed, then 360 No Slope, then Fuzzifiers, and finally OMU. The prizes for the competition, we have prizes for the playoff podium specifically. So we have a prize of $700 for first, $400 for second, and $200 for third. We also have prizes for explainability. So those will also be ranked for second and third according to the votes from the judges. Then we also have a prize for the most innovative solution. Again, a podium that'll be voted on by the same panel of judges. And then also the custom ship peer award, which I mentioned already. We're going to go ahead and show the peer voting results for the custom sprites. We did this using ranked choice, and so there were only 3 teams that submitted, so there were only 3 teams, and they can't vote for their own. And so each sprite only had votes. And so we awarded 2 points for each first place vote, and 1 point awarded for each second place vote. And the results were that Team Neo got first with 4 points, OMU got second with 3 points, and 360 No Slope got third with 2 points. And so that's our results from the peer awards this year. I really enjoyed the sprites. They're a lot of fun, so I'm excited to see them play the game. The results from the explainability and innovation scores,